Hi everyone, welcome back to the Math Society. So this week we'll be continuing on to do another Edexcel topic, which is bearing. So let's get right into it. Question number 1, it says that the bearing of village A from village B is 124, and we need to find the bearing of village B from village A. So let's first try to position A and B. And it says that bearing of village A from B is 124, so we know that it's 124. And we know that this still adds up to 180, so it's going to 180 minus 224, which will get an answer of 56. And remember to always write in 3 numbers for bearing. And we want the bearing of village B from village A, so we want this. So we know that it's going to be, the total is 360 degrees, right? Minus 0.56, so that's where you get an answer of 304. And that should be your bearing. And now moving on to number question 2, we see that the bearing of P from Q, so it's the same way. We'll position P and Q. So of P from Q is 0.63. We know that they both add up to 180 as well. So we'll get an answer of 117, and we need Q from P. So that's 360 degrees again, minus 107 degrees. So that will give you an answer of 243 degrees. Yeah, and now moving on to number question 3. So number question 3, it says that it gives 3 points with elevation of T from A. Of T from A is 32. So let's try to join these first. And enable T from C. So let's label these. So this being 32 degrees, T from C is 25, so that's your 25 degrees, and bearing of A from B is 195. So A from B, so it has to be this one, is 195 degrees, and bearing of C from B is 280. C from B is 280. So that's C bearing. It says to calculate the bearing in degree of C from A. So C and A. We want C and A, which is this one. And let's try, because we're going to find bearing, let's try to put a middle line first. Let me try to move this around a bit. Okay, sure works. And we want the bearing of C from A. So this is the bearing we want. So we need the other angles as well to find this little angle as well. So let's try to find, firstly let's try to find the AB length, because we have 32 degrees, so we can use the tangent rule, which is tangent O by A. So first it's tangent 32 degrees, right? Tangent 32 degrees of O by A. O by A, which is its opposite, it is 30, and A is the one that we want, which is AB, and that is tangent 32. So AB is going to equals to 30 divided by tangent 32. So that's going to give you an answer of 48.01 meter. And next we'll try to find the, okay, let me write it down first. So this is 48.01. So next we want to find the length of BC. We want to know what's the length of this BC, so we can know that we can use this degrees, which is 25, as in the same rule as in tangent. So this time it will be tangent 25. Sorry, is it 25? Yep, 25 equals to 30 by BC as well. So BC would be equals to 30 divided by tangent 25, which will give an answer of 64.3 meter. So now we know that this whole line is, was it 64.3? So this is 64.3 meter. So for now, we can find the angle of this angle first, which is angle CBA, because we can subtract 280 minus 195 to get that angle. So we see that they overlap. So angle C, I believe it was CBA, 280 degrees minus 195. which will give you an answer of 85 degrees. So this is 85 degrees. So we now get the 85 degrees because we need these other angles as well, and so we need to find the length of AC square. So AC square, we have one angle, so we know we can use the cosine rule, so which is going to be AC square equals to the two lengths, which is 48.01 square plus 64.3 square minus 2, 48.01, 64.3, and cos 85. So AC, which will give you an answer of 76.85 meter. And that should be your AC, 76.85 meter. That is your AC. And because we now know the AC, we know we can find the angle CAB. So we can find, let me change the color. So for now, we can find this angle, right? So to find this angle, we can use the sine rule, which is also like given here. So let's try to find the sine by using the sine rule. So as a sine, which angle are we finding again? It's angle CAB. So the one that's right opposite, which is 64.3, it's gonna equals to sine 85, and its opposite length, which is 76.85. So angle CAB, after you multiply sine 85 with 64.3 divided by 76.85, and you inverse with sine, you will get an answer of 56.5 degrees for angle CAB. So you will get an answer of 56.5 degrees, and that is your angle for angle CAB. And then we want the angle ACB, right? And we know we have three. We know all the other two angles, so it's angles in a triangle add up to 180 degrees, so we can just subtract it from there. So angle BCA or ACB, same thing. So that's 180 degrees minus 56.5 degrees minus 85 degrees. That's, you will get 38.5 degrees. And this is going to be 38.5 degrees. Okay, so now we want the bearing of C from A. Because we want a bearing of here, we need this little triangle, right? To know this little triangle, we need to know this angle. So, and after only knowing this angle, we can subtract it from 180, and we can later subtract more from 360 to get the small little angle. So first of all, if we will try to extend this line right here. Oh, okay, not really extending, but this one has to be a straight line, yeah? So we can say that it's 280, and we know that this side is 180, right? So this side is 180, so we know that this whole thing is going to be 100 degrees. And because the lines are parallel, so these lines and these lines are parallel, we know that this is also going to be 100 degrees. And we know that when it's in opposite, we know that this angle also has to be 100 degrees. So now we have two angles in a triangle, and we just want this little angle, which we can subtract it from 180. So you will, to get that little tiny little angle, which I'm gonna name it X, so that's gonna be X equals to 180 degrees minus 100 degrees minus, what was the other, 38.5. And that's where you get 41.5 degrees. So this little x is now 41.5. So because we know this little x, if we subtract only this x, we can get this bearing as well. So that's going to be, to get the bearing, it is just going to be 360 degrees minus 41.5 degrees. And that's why you'll get an answer of 319 degrees rounded off. So that should be your bearing. And now let's move on to question number 4. So moving on to question number 4, we can see that they've already given you the position and parts and everything, and we know that they two add up to 180, so we just need to subtract it. So that's 180 degrees minus 133 degrees, which you'll get 47. And we just want to know a degree of x, right? So that's, we know that this one's 90 degrees, so we just minus it off. That's why you get an answer of 0.43 degrees, and that's your answer. So now moving on to number 5, this is a little more complicated. So 5, A, P, and B, 3 points on horizontal ground. PQ is a vertical tower. Angle of elevation of Q from A is 16.9. 3B. So let's calculate A first. So now PQ are going to be on a straight line where PQ is a tower. So okay, PQ on a straight line. Oh no, sorry. P and A with Q as in tower, right? A of Q from A 16.9 degrees, and show that the height of the tower to 3 significant is 304. And A, this is 1,000 meter because it's in kilometers, and it asks you to find in meters as well. So we know we can just use the rule, the tangent rule, which is O by A. So that's just tangent 16.9. O by A, which is PQ by A, 1,000. So PQ is just going to be 303.8 meter. But when you round it off, you get 304 meter. And that's the same. And that's the same as the one that they asked you to show. And now another one is that B is 2 kilometers due east of P. So I hope we know our north, south, east, west. So we're gonna have it as A and P in this way now, and B is going to be probably have to go down a little lower. So we'll have this as AP and B. Yep. So then we know that it is AP, which is 1 kilometer as well. And this is B, and it says B is due east of P with 2 kilometers. So we know that it is 2 kilometers. And we know that this is 90 degrees. And BC is a vertical radial mass. So we know that BC is a vertical radial. So let's go a little here. And we know that we still have a PQ as well, yeah? So this is going to have to be PQ. Let me just draw it a little longer. Yep. And this is PQ. This is PQ. And then from B, BC, it has to be C. This one is going to have to be C. Angle elevation of Q from C on the top of the radial mass is 8.2. So let's try to imagine this as a triangle. So we know that this one is 8.2 as they have mentioned. And it says that it asks you to calculate the size in degree to 1 decimal place of the angle of elevation of C from A. So C from A, which will join after. But first of all, we need to find the X, which is this little place, because we know that this whole PQ is 304. So that we can try to find the length of BC. So we know that we have to find this little X first, which is going to be tangent 8.2 equals to, and we know that the length is 2 kilometers, which is 2,000. So that's going to be X by 2,000. So X is going to be tangent 8.2 multiply 2,000. and that's going to give you an answer of 288.2 meters. And we know we want BC. We want BC. So that's 304 minus 288.2, and that will give you an answer of 15.79 meters. And to get the tangent, to get the size of C from A, so we know that we want this little, let me just draw it out again. So we know that we want this little place, right? We want this little angle, and we need to find the length, which is AB squared. So we know that it's a right angle triangle, so you can use the hypotenuse rule, which is going to be AB squared equals to, let me just write it down first, 1,000 kilometers squared, not 1,000 kilometers, 1,000 meter plus 2,000 square. AB with the root of 1,000 square plus 2,000 square, you will get an answer of 2236.06 meters. So this is 2236.06 with BC being 15.79. So now if you want the angle, you can use the tangent rule again, which is O by A. So tangent, we're gonna name it theta. That's equals to 15.79 divided by 2236.06, and you'll get an answer of 0.4 degree, and that is your angle of elevation of C from A. Okay, and I believe this is the last one. So that's it for today's video, and I'll see you in the next video as well.